There is one equation that tells a physicist how fast a ball is falling and tells a trader how fast their portfolio is growing. It is the same equation, same structure, same logic, same answer. The only thing that changes is what you are measuring. That equation is the derivative. And by the end of this video, you will never see motion or money the same way again. In physics, imagine you are tracking the position of an object over time. You draw it as a curve. At any point on that curve, you can ask, how fast is this thing moving right now? Not on average, right now, at this exact instant. The answer is the slope of the curve at that point, and that slope is what the derivative gives you. Watch this line. As it moves along the curve, the slope changes. That changing slope is velocity. Now, forget physics. You are looking at the price of an asset over time. Same curve, different label on the axis. You can ask the exact same question. How fast is this price changing right now? The slope of the curve at any point tells you the instantaneous rate of return. Same question, same math, different universe. But how do you actually calculate that slope at a single point? A point has no width. You cannot just draw a triangle. Here's the trick. You pick 2 points on the curve and draw a line through both of them. That line has a slope you can calculate, rise over run. Now you slide the second point closer and closer to the first. The line rotates. It gets closer and closer to the true slope at that point, and in the limit, as the gap between the 2 points reaches 0, you get the derivative. This is the formal definition. F prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. Every derivative you will ever compute comes from this. Let us use it. Take f of x equals x squared, plug it into the definition. F of x plus h is x plus h squared. Expand that. You get x squared plus 2, xh plus h squared. Subtract f of x, which is x squared. The x squareds cancel. You are left with 2xh plus h squared in the numerator. Factor out h, cancel it with the denominator. Now take the limit as h goes to 0. The h term disappears. You are left with 2x. That is the derivative of x squared. In physics, if your position is t squared, your velocity is 2t. In finance, if your asset price follows t squared, your instantaneous rate of return is 2t. Same calculation. Two completely different meanings. This is the thing that most math courses never show you. The tools of physics and the tools of quantitative finance are not just similar, they are identical. The derivative, the integral, differential equations, stochastic calculus, all of it crosses over. When you learn this math, you are not learning it for one field. You are learning the language that both fields are written in. That is QuantForge. Every video on this channel will do exactly what we just did. Take one piece of mathematics and show you what it builds in physics and what it builds in markets. Next video, we cover the integral, the flip side of the derivative, and what it means for energy stored in a system and for wealth accumulated over time. See you there.